All right, 7.1 is about linear and nonlinear systems of equations. Let's jump right in. Many problems in science, business, and engineering involve two or more equations that are themselves composed of two or more variables, like x, y, z. In order to solve such problems, we need to find solutions. First time teaching in a while, of a system of equations. So an example of what that might look like would be like this. We're going to open up a curly bracket, and maybe you're going to have one equation that's 2x plus y equals 5, and another one that's 3x minus 2y equals 4. Now, that's the system, but we're going to try to solve that system. So a solution of this system is an ordered pair. Sorry, waiting for air to catch up, but I'll keep talking. So a solution of this system is an ordered pair x, y that satisfies the equation of the system. Finding the set of all solutions of this system is called solving the system. So we're going to work on solving the system, and one method we have is substitution. So starting off, we're going to use that same system as we had above. Sorry, let me make sure this is on my screen properly. There we go. So we had 2x plus y equals 5 and 3x minus 2y equals 4. And we're asked to show that the ordered pair 2, 1 is a solution to the system. So let me rewrite that system. We had 2x plus y equals 5. The other one, 3x minus 2y equals 4. Now, if 2, 1 is a solution, if I plug in 2 for x and 1 for y in both those equations, both of those statements should be true. So let's check it out. We got 2 times our x value of 2 plus 1 equals 5. Is that true? We got 4 plus 1 equals 5. That's true. Cool. The second one, if we do 3 times 2 minus 2 times the y value of 1, checking to see if that equals 4. Well, 3 times 2 is 6, minus 2 is 4, so that also works. Now, this method of substitution, it works really nicely if you have just the x and y values and you're asked to plug them in. But the other way we can go about it is as such. I'm going to take that first equation, 2x plus y equals 5, and what I'm going to do is I'm going to set this in a format that we're more familiar with. Sorry, waiting for AirServer to catch up again. All right, sorry about that. Now we're working again. We got 2x plus y equals 5. Now, if we solve this in a more familiar way, getting the y value by itself, if we subtract 2x from both sides, we end up with y equals negative 2x plus 5. Now, what we can do with this is substitute it into the other equation. So the other equation we had was 3x minus 2 times y, but now instead of y, we're going to plug in that negative 2x plus 5. So again, we're grabbing it from there. And it's still equal to 4. So cleaning this up a little bit, we have 3x minus, now I'm going to distribute the 2 to both of these, or if you want to distribute a negative 2, I'm going to distribute the whole negative 2. So we got negative 2 times negative 2x, which gives us plus 4x, and then negative 2 times 5 gives us negative 10 equals 4. Cleaning this up just a little bit more, we got 7x minus 10 equals 4. Let's just add 10 to both sides. So we got 7x equals 14, and if you divide both sides by 7, you get x equals 2. Well, we already knew that. That's great. Now, to check to make sure that the other one, the y value is actually true, we're going to go back and plug it into this equation back up here. We had y equals negative 2 times that new x value of 2 plus 5. So we got y equals negative 4 plus 5, which gives us y equals positive 1. So that is another method of solving if you weren't just given the equation, or given the solution. Now, the steps we can take for solving this using the substitution method. We first solve one of the equations for one variable, just like we did. Then substitute the expression that you did in step 1 into the other one. We did that as well. Then solve the equation that we got, exactly. Back substitute in what we had in step 3, or what we found in step 3, back into step 1, so it's a little easier. And we'll check the solution by plugging it back into the original 2. Let's check this out. Usually when looking at these types of problems, there's often one that's a little easier than the other. So I'm going to start with this one. it's going to be easier to get x all by itself. So for step 1, I'm going to take x plus 4y equals 3, and let's subtract 4y from both sides. And we have x equals negative 4y plus 3. Now, taking that, we're going to take that and plug it into the other equation. So the other equation was, let me switch colors a second. It was 2x, but instead of x, my apologies, we're going to replace it with negative 4y plus 3. And then finish off that with second equation, minus 7y equals negative 24. So we're going to distribute the 2 to both of those. So we got negative 4y plus 6 minus 7y equals negative 24. I'm going to do kind of a couple steps in one here. I'm going to subtract 6 from both sides, but also combine the like terms on the left side. Negative 4y minus 7y gives us negative 11y. And then, oh my goodness, anybody see a mistake I made? I made a mistake. That was supposed to be an 8. 2 times negative 4 is negative 8. Goodness gracious, I don't feel like making this video over. So let's keep going. So we got negative 8. Negative 8 minus 7y gives us negative 15y. And then equals, on the other side, negative 24 minus 6 is negative 30. Go. Now let's divide both sides by negative 15. And we end up with y equals 2. So that was really step 3. I kind of forgot that steps 2 and 3 kind of merged together. Step 2 is plug it in, step 3 is solve. I just kind of do it all in one. The numbers of the steps aren't the most important thing you can do. Now, what we're going to do is we're going to go back and plug it back into the equation we had in part 1, where it was x equals negative 4. Now instead of y, now we know based on what we just got that y equals 2. So we have x equals negative 8 plus 3. Which gives us x equals negative 5. So our solution we have is negative 5 comma 2. Now we should check our work. So step 5 is check your work. So we're going to go through and plug it back into the original equation. So we had negative 5, our x value. I'm going to put that in parentheses just to get in the good habit. Plus 4 times y, which was 2, equals checking to make sure that it's equal to 3. So we have negative 5 plus 8 equals 3. It sure does. The other one, plugging it in, we're going to do 2 times negative 5. And then we got minus 7 times our y value of 2. Checking to see if that's equal to negative 24. We got negative 10 minus 14 equals negative 24. It sure does. So always go back and plug those back in just to double check. Letter B is going to take a little bit more work because we have a quadratic there, so it's a little more complicated, but the same principles apply. Look for which one you think is going to be a little easier. I think the second one's going to be a little easier to deal with. So for step 1, I'm going to take that second one and solve for a variable. What I'm going to do, this is not the only way you can do this, but I'm going to add y to both sides, but I'm also going to add 1 to both sides. So we have 2x plus 1 equals y. Now for step 2, we're going to plug that into the other equation. So we're going to plug it in for the y value. So we had x squared plus 4x minus, instead of y, we're going to plug in 2x plus 1. And that's equal to 7 still. Now we're going to just subtract the 2x and subtract the 1. So we got x squared. Then 4x minus 2x is going to give us plus 2x. And we're going to have a minus 1 equals 7. Going through what we've done with quadratics in the past, let's get everything on one side. So I'm going to subtract 7 from both sides. We got x squared plus 2x minus 8 equals 0. From here, we can factor it out. And we got x, two numbers that multiply to negative 8. We got positive 4 and x minus 2, because they also have to add to the b value of 2. From here, we can see that using the zero product property, x equals negative 4, or x equals positive 2. Sorry, that whole solving process is technically step 3. Again, the labeling of the steps, not the most important thing you can do. Now for step 4, we got to solve for the other variable. Now the problem is we have two x values. Well, that means we're going to have to solve it twice. So let's start with x equals negative 4, and over here we'll do x equals 2. So we're going to go through and plug it back into what we found in step 1. So we have 2 times that negative 4 plus 1 equals y. So 2 times negative 4 is negative 8 plus 1 equals y. So we end up with y equals negative 7. So one of our solutions is negative 4 comma negative 7. For the other one, we're going to do 2 times our x value of 2 plus 1 equals y. So we got 4 plus 1 equals y. In other words, 5 equals y. So the other coordinate is 2 comma 5. Now, for now, I'm going to skip the, oh, that was a horrible box. Let's do that again. I'm going to skip the check your work process just for time's sake. But again, plug those values in, negative 4, negative 7. Plug those into the x squared minus 4, sorry, plus 4x minus 7. And also 2x minus y equals negative 1. Make sure that works. And same thing for the 2